Welcome to another 341 sample video. This one is looking at what happens if you blur an image with a Gaussian kernel and then you blur the same image with a Gaussian kernel of a different size and then take one away from the other. So what I've got here is it's a black and white video feed from the back of some boring meeting or other, and it's actually blurred with a very small Gaussian kernel. And then what I do is I take exactly the same feed and you blur it with a bigger kernel, basically make it more blurry, and you end up with two versions of the same image but with different levels of detail in them. Where it becomes interesting is where you say, right, we're going to take one of these away from the other. So you take an image that's blurred with, say, a kernel of 3, and then you subtract from that an image that's blurred with, say, a kernel of 5. And what you get there is you get quite a good highlight of all of the fine detail in the scene. So you can see the twigs in the trees behind, and you can see bits of hair and so on. And the fine details exaggerated. When you make the kernels bigger, what happens is the fine detail disappears, but the broad brush detail is kept. And this technique is key to a lot of feature detectors, particularly those that work at different scales, like David Lowe's SIFT. By using Gaussian blurs and subtractions, difference of Gaussians at different scales, you get to highlight different parts of the image and different types of feature.